Hi, this is Mr. Mac. This is a concept video that covers transformations on some basic functions. Now, in Algebra 2, one of the things that we're attempting to foster in students is a mathematical maturity. Now, this mathematical maturity can take upon itself the appearance of a student being able to look at an equation of a function and having an idea of what its graph looks like from an examination of the function. Now, how will we do that? Well, what we do is, number one, we identify some basic functions. And then number two, we learn what transformations take place to those functions. And their graphs. Now, so let's start with four basic functions. What we're going to do today is we're going to define four basic functions. We're going to define, one, a constant function. We're going to define an identity function. We're going to identify, or we're going to also include in this basic list of functions the absolute value function. And finally, our fourth basic function is going to be the quadratic function. Now, constant functions will be of the type y is equal to k, where k actually stands for some constant. For example, y equals 2 or y equals -3. These will be constant functions. Now, the identity function is the one that actually just gives you what you give it. So that would be y is equal to x. The absolute value function is y equals the absolute value of x. And the basic quadratic function will be y equals x squared. Now, it's important for us to know what the graphs of these four basic functions look like. So let's take a look first at the constant function. I'll just move all of these things down some and take a look at the constant function. Now, for example, let's say we have the graph y is equal to 2, or the function y is equal to 2. That's a constant function where 2 is the constant. Now, if we didn't know how to graph this, one of the things we could do is we could make a chart for x and y. Remember, when you're making a chart, you choose x's and you find out what y is. So let's try this. What if x is 0? What is y? Well, you look at the function, it says y equals 2. What if x is 5? We look at the function, it says y equals 2. What if x is -1? Well, we look at the graph, y is 2. Now, the function doesn't listen to our input much, but it does give us an answer. So let's plot these points just quickly and see what we get. Now, we have 0, 2. That's this point right here. We have 5, 2. And we have -1, 2. Now, I think you can see if we were to plot more points, we would pick x's, y would always be 2, and so we would end up with this line. Now, to describe this line, it's a horizontal line going through 2 on the y-axis because, of course, y equals 2. So the constant function will be a horizontal line going through whatever the constant is on the y-axis. Let's take a look at the second function. Y is equal to x. Let's move this stuff out of the way again. Okay, if y is equal to x, once again, let's just make a little chart for x and y. So if x is 0, y is 0 because y is equal to x. If x is 1, y is 1 because y is equal to x. If x is negative 2, y is negative 2 because y is equal to x. 3, 3. This is enough points, perhaps. Let's plot them and see what we get. Now we have 0, 0. We have 1, 1. We have negative 2, negative 2. We have 3, 3. It's pretty easy to see that if we plotted more points, what we would end up getting would be a diagonal line going through the origin, going up to the right at 45 degrees. And this is going to be our identity function. So when you see y is equal to x, you should know that the graph of y is equal to x is a diagonal line going through the origin, going up to the right. Now the next one we want to look at is the absolute value function. Oops. Now, that would be y equals the absolute value of x. Now, if we again make a chart for x and y, we could start with 0 for example for x. If x is 0, y is the absolute value of 0, which is 0. If x is 1, y is the absolute value of 1, which is again 1. If x is negative 1, y is the absolute value of negative 1, which is 1. If x is 2, y is the absolute value of 2, which is 2. And if x is negative 2, y would be the absolute value of negative 2, which is 2. Now, I didn't write that down. Don't quite have enough room, but you get the idea, I'm pretty sure. So we have 0, 0, 1, 1, negative 1, 1, 2, 2, negative 2, 2. I didn't write that one down, but we did find that one. And so notice what we get with the absolute value is a thing that looks a bit like a V. Now, one of the things I like to tell students is that if you are graphing any kind of an absolute value function, if you haven't found the bend or the crease in the function, you haven't plotted enough points. Well, we found it. It's right at the origin on this one. So that's what the absolute value function looks like. And the last one of the 4 basic functions we're going to define today. Now, we will have more basic functions later, but right now, this is the 4 that we're going to work with. We have the quadratic function, or y is equal to x squared. Now, if we have y equals x squared, we could, again, make a chart, x and y. And if x is 0, we square 0 to get y, which is 0. If x is 1, 1 squared is 1. If x is negative 1 squared, negative 1 in parentheses, squared outside, gives us 1. 2 squared is 4. Negative 2 squared, negative 2 times negative 2 gives us 4 again. 3 squared gives us 9. Negative 3 squared gives us 9. So if we were to look at the graph of these points, we would have 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, 3, 9, negative 3, 9, and then if we connect these points with a smooth curve, we get the graph for y is equal to x squared. Now, this graph has a name. We call it a parabola. Now, also, it's kind of important for you to understand the shape of this quadratic function. So let's examine it in a little more detail. First of all, this turning point right here, or the nose of the parabola, is referred to as the vertex. Now, once you know where the vertex is in the squaring function or the parabola, in this case it's at 0, 0, but some of our transformations are going to move it around. Notice that to get another point on the squaring function, you would go 1 to the right of the vertex and you would go 1 up. If you went 2 to the right of the vertex, you would go up 4. If you went 3 to the right of the vertex, you'd go up 9. Well, that's pretty obvious if you think about it, because 1 squared is 1, 2 squared is 4, 3 squared is 9. But if we move this parabola someplace else, it's still going to have those same characteristics of going from the vertex 1 to the right, 1 up, 2 to the right, 4 up, 3 to the right, 9 up. Now, if we go 1 to the left, we're going to go 1 up. If we go 2 to the left from the vertex, we're going to go up 4. If we go 3 to the left from the vertex, we're going to go up 9. Now, the basic quadratic function, if we just slide it someplace, will still have those characteristics. And that's one way to find some points so that you can do a good job of graphing the equation. All right, now those are our basic functions. We have the constant function, once again. We have the identity function. We have the absolute value function. And we have the quadratic function.